Now, there's a couple of things I want to tidy up, and I also want to finish off my kind of preview of the assignment. Everybody has read the assignment spec now at this stage. And then I'll give you an opportunity for some Q&A if you've got questions relating to it. I don't see this session now being taking up the full 2 hours. Right, so everybody has done the Cognito lab at this stage, but I just want to maybe highlight something that might be of interest to you. If we fast forward to, let's see. Yeah, this kind of diagram illustrated the full architecture, I guess, of the Cognito lab, and not coincidentally, the architecture of the assignment as well. And we know how it works now at this stage. So just to pick up the story, let's say the user has logged in at this stage, and they have their JWT token, and now they want to access some lambdas over here on the right. So what happens, as we know, is they send a request which includes the token, and I've uh, wrapped the token in the cookies header. This gateway, first of all, passes the request. So whatever request arrives at API gateway, it passes that request, the full request, to this Lambda, which we call the authorizer. And that checks with Cognito that the JWT token is valid. And if it is, then it tells the gateway, okay, you can allow the request to go through, and it goes through. So whatever this authorizer receives, and it receives the full request that came in to Gateway, that exact same request is passed on to the Lambda that's over here. Yeah. So the Lambda that's here and the Lambda that's here see the exact same request. And we know the request is wrapped inside an event, but so it has this Lambda over here has access to everything that this Lambda has. And if we go back to this Lambda, this authorizer for a second, and if we go into the code, and I don't need to talk my way through this now fully again with you, but in overview terms, the first thing that the authorizer does is it takes the cookies header and it kind of parses it up. In general, as we know, the cookies header value will be just a big long string, but when it's parsed up, um, the string consists of individual cookies. A cookie is a key value pair, and the parsing of the cookies header, the kind of the separator between the individual cookies, is a semicolon, I think. And so either way, anyway, we do that parsing in the utilities function that we just briefly looked at the last day. So um, so right, this is our little map data structure, and we extract out one particular cookie from it, the one whose key is token. And then we essentially call this utilities function, passing it the cookie value, and that utility function goes away and talks to Cognito, and Cognito validates the cookie. What I want to just focus in on is the function returns this object here, right? And I'm console logging the object for you. And so I wonder what is the structure of that object. So if I go over to, so what I've done already is I have in Postman, I've signed up as user A, kind of what we did in the lab as well. So I've signed up as this person. My username is user A and password and email. I've logged in, so I have my cookie, and then I submitted a request to the protected Lambda. Yeah, and I want to see in CloudWatch logs, what does that console log statement throw up, right? I want to see what this console log generates. In other words, I want to see what is the structure of this object here. And before I show it to you, the answer is the structure is the decoded or decrypted or decoded contents of the JWT token. Remember, this is a screenshot I showed you the last day from a website, and if you just paste in a JWT token in its kind of encoded form, and on the left, what you get on the right is the uh, decoded form of that, and that contains some useful information. For example, it contains the user's username, the person that actually the token was issued to. Now, it's this exact structure. That's what my console log is actually going to give back to me as well. And I can kind of prove that, gee, if I go into CloudWatch logs, so I've got two log groups here. And the reason I've got two log groups is, so I know if we're kind of jumping around the place, but I've got one log group for this Lambda because that was triggered. And I've got a log group for the Lambda that was over here, which was also triggered, the kind of protected Lambda. Yeah. So if we look at this one, and look at its log stream. So it starts here. This one here is the console log of uh, the event itself, the event that the Lambda received, which is essentially the HTTP request that came into API Gateway. And well, okay, let's just open that up. And look, here's the cookie, the entire cookie header value. There's only one cookie in my cookie header, but that's essentially the JWT token in encoded form. Yeah, so that's okay. Let's collapse that. And this is the console log of that object that I was talking about. And if I expand that, here's the actual structure, the decoded form of the JWT token. And for example, here's the username. It was issued to a user whose username was user A. So this property here, cognito dot username within the object will give me the username. Yeah. Um, the other log group, this is the log group associated with the protected Lambda. That's the Lambda. that's over here that contains the functionality, Maria. And if we look at the event object that it receives, we'll see that it's the exact same event object that this one receives. So whatever it can do, this can do as well. Again, uh, this is the console log of the event object, and if we blow it up, here's the cookie header. Okay, just wanted to make you aware of all of that. The next thing, I think I can go to the assignment spec now, maybe. I'll just pause for a second in case there's any questions about what I've just shown you there. No? Okay. So everybody has read through the assignment spec now, and I talked my way through some of it last day. It's quite a long specification, but the length is necessitated by me having to describe the structure of the DynamoDB table. That's taking up a lot of space, and I felt it was necessary that I give you that detail. And I talked about that the last day, so I'm not going to go over that ground again. Now I cheated a tiny bit. I made some tiny changes to the spec yesterday, and I just want to highlight those to you. The changes mainly relate to clarifying maybe parts of it that I thought may not have been clear. Like if we take this particular endpoint of our REST API, get/awards, and then there are these query string options that are possible in the request. And we know the query string options, by definition, they're optional. So any kind of combination of these query string keys could be included in a request. And so there's three different possible query string. So there's what, 2 to the power of 3, is it? The different combinations or whatever it is. I should have checked my maths beforehand, but so I'm kind of detailing there's a lambda behind this endpoint that's meant to get the necessary data that the user is looking for. And so I'm telling you, if the query string contains a movie ID and an actor ID, if it just contains the movie ID alone, then what the lambda should do is retrieve all of the table items that relate to awards won by that movie. So it may have won an award, it may have won an Academy Award and a BAFTA award. It may not have won any awards. Okay, so that's what it should return if the query string only contains a movie ID. If the query string contains a movie ID and an actor ID, then it's meant to return all of the table items that relate to awards won by that movie and that actor. Not necessarily that the actor was in the movie, that they're just two separate things, if you will. We want all the awards won by this particular actor and all the awards won by this particular movie. If the query string contains both a movie ID, an actor ID, and an award body name, then we're only interested in awards won by the movie for that particular award body and also awards won by the actor for that particular award body. So it's kind of a subset of this one, if you like. And on and on it goes. If there's just a movie ID and the award body, then I guess, oh yeah, the other thing, and it's later on in the spec, the other change I made to the specification was to say that we need to assume that an actor can only win one award with a particular award body, and also a movie can only win one award with a particular award body. Now, certainly the latter of those two isn't necessarily reflective of real life because quite often, as we know, a movie could win multiple awards for a particular award body, as in it could win multiple Academy Awards, let's say. But we're just going to assume that a movie can only win one award with a particular award body. I could have made changes to database, um, the database primary key, how I designed that, such that we could accommodate the case where movies could win multiple awards. But that would just be another layer of complexity, which we don't necessarily need to um, include in this spec. So there is that constraint just on the award side. So back to here, if the query string contains just a movie ID and an award body name, then potentially that's going to just return one item because there could only be one matching item. There may not be any. Uh, Similarly, for actor and award body, there's either one item in the table or none. And then there are some other options as well. I think I got tired at this stage with going through all the different combinations and permutations, but hopefully you get a sense now from these specifics as to what should be returned for the other possibilities um, in the combination. Any questions about that? No. Okay. So I talked through all of this the last day, the different types of data items in our problem domain, actors, movies, casts, and awards. So that's all okay. Then we talked about the DynamoDB table design, this single table design, and that's really where there's a lot of space taken up in the spec uh, explaining that because, as I said at the outset, I felt that was necessary because we're not heavy into databases in this module. And so I'm going to fast forward to, so I'm giving you some examples of a movie record, a movie item, an actor item, and the intent of that was to kind of clarify the kind of explanation that's going on up here. So just to be clear now, from the outside world's perspective, the outside world knows about, let's say, a movie ID. Movie IDs might be 1, 2, 3, 4. In the database, the partition key for that movie is M1234. The outside world doesn't know anything about partition keys or sort keys. Yeah, so that's just an important clarification as well. Again, I'll repeat it. The outside world just understands, if we just focus on movies, it understands movie IDs. It knows about movie IDs, and they're just ordinary numeric values. The fact that within the database, the partition key equivalent of a movie ID has this M prefix, the outside world doesn't really know about that or need to know about it. And the same goes for kind of actors. An actor's ID might be 1, 2, 3, 4 as well, but the partition key equivalent of that within the table is A 1, 2, 3, 4. Okay. Sorry, just let me go back to. Oh yeah, yeah. This is the line that I slipped in there yesterday. This assumption that a movie or an actor can only win one award within a particular award body. We can make that assumption. That's roughly where I left it off the last day. then when it came to the whole area of authentication for our web API, turns out that there's going to be two forms of authentication. There's going to be authentication which applies to, let's say, ordinary users, and they will be accessing our web APIs by, first of all, registering. Uh, this obviously brings in Cognito, so they register using Cognito. They provide a username and password and their email address, and all of that stuff, right? So, as I've already said to you, all of that Cognito code that you used in the Cognito lab, you're free to pull that into the assignment solution and plug it into your web API. So we know all about that, and I don't need to go over it. The additional aspect of authentication is, let's supposing as well as an ordinary user, and ordinary users, I say later on, they can only access the HTTP GET endpoints in our API. Excuse me. Ordinary users can only do this kind of stuff. Ordinary users cannot do the post. They can't do the post and they cannot do the delete. Those actions are reserved for an administrator. But when an administrator wants to send a post request to this endpoint or a delete request to this endpoint, the administrator must include an API key. And API gateways, the API gateway service, not the Cognito service now, the API gateway service, it comes with this API key kind of support. In fact, if I just switch over to, and if I go to the gateway service, you can see here on the left, right, you can have API keys as well. And I don't have any API keys at the moment, but if we had an API key, and the API key is independent of the actual web APIs. So like, okay, we have two web APIs, but we could have API keys as well, that are, as I said, independent of the APIs. Now you can connect them up, and I'll talk about that in a moment. But so from the specs point of view, the administrator, when they want to carry out either of these two actions, post or delete, they're not going to be including a JWT token in the request. That doesn't apply. Instead, they will be including an API key in the request. That request goes into a different header now, doesn't use the cookies header. I just have two slides that might be useful to you on that topic. Clearly, you need to read up a little bit on API keys in relation to the AWS API Gateway Service. But I've added two slides into to the end. I've added them on to the end of the Cognito slides, and you will be able to access these two slides yourselves. I only uploaded it there about an hour ago. So, I mean, you're familiar with API keys. You're certainly familiar with them from the Web App Dev module last year, because if you remember, you had to ask TMDB to generate an API key for you specifically. And that's kind of what we're modeling this on in a way. And I'm sure you use API keys with other services that you use as well. And we know what an API key kind of structurally is. All it is a kind of an alphanumeric string. And Typically, they're kind of issued to in relation to giving developers access to particular web APIs. Okay, we're not doing it in that context now. We're doing it in the context of giving an API key to the administrator to allow them to perform post and delete requests. And as I'm saying here, you can get the API gateway to generate an API key for you. So this is code now that would go into your CDK kind of stack code. You'd have some code in there which is telling the API gateway service to generate an API key. And as I've already said once or twice already, that key generation is completely independent of the fact that you may or may not have RESTful web APIs as part of that CDK stack as well, although typically you would. But so you can get the API gateway service to generate an API key. I mean, you can do it from the management console as well, but we're not going to do that. We like using CDK, so we need to find out what is the CDK code, or you need to find out what is the CDK code to achieve this. Now, as well, there is this concept of user plans. And what are user or usage plans? Sorry. Usage plans are kind of detail the kind of restrictions that you want to impose on accessing your web API in terms of maybe setting an upper limit as to how many requests you're allowing a person to use on your web API over a particular period of time. So it's kind of a rate limiting, and you can impose other constraints as well on access to your web API, and you describe those in what's called a usage plan. And the idea like is that if the user exceeds the usage plan that is assigned to them, and it's not so much that a usage plan is assigned to a user, a usage plan is actually associated with an API key. That's the kind of the connection there. And the usage plan, if the user exceeds the usage limits that are defined in the usage plan, then they receive a kind of a throttling error response. Now, we don't really have any rate limit requirements in the specification for this assignment, but we still need to declare a usage plan, and we need to link the usage plan to the API key, and this is all done in the CDK. So the CDK has code that generates an API key. It'll have code that generates a usage plan, which the only thing you need to do is well, I'll talk about it in a minute, but so that's the concept of a usage plan. And again, they're kind of independent. When you declare them, they're independent of the keys as such. Again, if I switch over to you can see here as well, right? There's usage plans as part of the whole API gateway service. And equally, I don't have any at the moment. Now, on the next slide, what I'm trying to do here is describe the relationship, because there are three, and maybe more than three actually. There are probably, what is it, 5 different components that are kind of playing with each other here in a way. So we have our RESTful API. That's what you're mainly building in the assignment spec. Okay, this is the kind of, not the Cognito one now, but the other one, the main functional one. So we have that, and that's generated from the CDK code. What you will also need to do now is have some CDK code, and it's only a couple of lines really, which declares a usage plan. And the direction of the arrows here, what I'm trying to convey here is that the usage plan refers to the RESTful Web API instance. It's not the other way around, actually. You might think that the RESTful Web API that you declared points or refers to, as part of its configuration, it refers to a particular usage plan. It actually is the other way. And over here we have an API key, and equally your usage plan kind of refers to a particular API key, because there could be many, right, within your account, within your AWS account. So those two arrows there, that's what connects a RESTful Web API with a usage plan and an API key. But this is almost the central part of it. You might think this should be the central part. A web API has many endpoints. That's okay. We know how to code those in our CDK. And the endpoints are linked to Lambdas. That's okay. We know all about that too. If you want to secure a particular endpoint, and we definitely want to do that. So this might be the endpoint that relates to the Lambda that handles post requests. Yeah, so we want to secure that. We don't want anybody to be able to trigger that. All we need to say is we want this endpoint to be secured by an API key. We don't have to specify which API key. We just have to say, it's almost a Boolean like that. This endpoint will require an API key for it to be accessible by an end user. But because this endpoint is linked to this RESTful Web API, and this RESTful Web API is linked to the usage plan, and the usage plan is linked to this key, then implicitly what the RESTful Web API will do is it will check that any request that comes in from a client that's trying to access this endpoint, it must include this API key in it. Otherwise, it won't let it through. But from a CDK coding point of view, all you've got to say is you've got to declare your usage plan. You've got to declare your API key. You've got to build up your RESTful Web API. You've got to connect those three together in the way that I mentioned, okay? You do it in the usage plan. You've got to just tag your endpoints as being ones that require an API key. It's just a Boolean, really, true or false. And then, API Gateway kind of takes care of the rest. It'll take care of, as I said, when a request comes in and the request is trying to target this endpoint, it will check that the request includes the API key. And if it is, then it lets it through. Now, if there were kind of usage limits actually defined in the usage plan, which we don't need actually, then it would also ensure that those limits weren't being exceeded, that the number of requests coming into this endpoint that had a particular API key, that it didn't exceed those limits. More generally, which we are not concerned with, there may be many API keys, okay, which would each have their own usage plan that would all be linked to the one web API. And each API key presumably is issued to a different user. So hopefully that diagram at least gives you an understanding of the different kind of components that are related to the API key requirement within the spec. So you need to do some Googling on usage plans, API keys, in relation to CDK. And when you have the CDK code then for this guy and this guy, when you deploy that application, all you've got to do is, you don't really care about the usage plan. All you've got to do really is go to the API key section, and you'll have an entry here. Just get the API key value itself, which will be probably either this one or it'll be over here somewhere. Uh, I guess it'll be this column here. Get that actual value, and then you need to include that key value in your requests. Like when you're in Postman, you'll have a Postman request here that's targeting, let's say, the post endpoint in our Movies API. And you need to include that key as in one of the HTTP request headers of that post request. You do need to find out which header is it, because it is a specific header. I don't think you could control which header is used to contain the API key. So back to the spec. Um, that's my kind of heads up for you on this feature. So clearly, like we haven't covered it in the labs or lectures, so it's something you need to um, try and discover yourselves. I will leave time for Q&A at the end, but right now, let's say on this point, are there any questions that hit you? No? Okay. The stuff is straightforward enough. The next thing is this logging feature. Um, Hopefully it's straightforward enough in terms of what we want to achieve. The idea is that for every request targeting one of the get endpoints, and we know that it's ordinary users are typically using the get endpoints, and by ordinary users I mean those that have registered um, via Cognito, so a user that has a username and password. Yeah. Uh, which means they have a JWT token when they log in, and et cetera, et cetera. So every request that finishes up in a Lambda endpoint that's processing a HTTP GET request, that Lambda just needs to do a console log where they will log the username of the user that's issued the request and just the full path of the request that they made. And you'll get this part here in the event object if you just open up the event object. And the event object contains essentially all of the HTTP data that was included in the request. And you just need to console log out that, just console log. And if you do a console log, we know it finishes up in our CloudWatch log stream. That's it, right? That's all that needs to happen to satisfy this logging requirement. It's something that would be done in industry as well. Like the idea, the reason, as I say down here, the reason we would be console logging this kind of information into the log stream is because we might have another Lambda somewhere else that's actually reading through the log stream and picking up all of these entries in the log stream. It would skip the entries that don't have this structure and maybe generate some statistics on how many requests were made by a particular user, what's the distribution of requests across the various endpoints that a particular user made, all that kind of stuff. Right, so that would be the kind of the analytics side uh, of this logging feature. But we're not concerned with the analytics side of it. That's that. The last feature is what I'm calling state change. Now, if I go back to something I talked about a long time ago, if I go back to these slides here, when we just started talking about not only serverless, but in particular, we started talking about Lambda. And let's see now, where is it? Yeah, the Lambda integration uh, models, and we said there were three Lambda integration models. Lambda integration relates to how other services can trigger a Lambda. Yeah. And we had the synchronous integration model, the asynchronous model, and um, the polling model. So this diagram here is just one example of the polling model. And you might remember the idea here was you've got a client. Sorry, no. What happened there? Sorry, bear with me for a second. I don't know where I'm going to now. Just give me a second. Where am I on this slide? Sorry, right. Um, you've got a client that's writing, that's making changes to the database. In our case, the client is actually a Lambda as well, right? But it could be anything. Um, well, let's stick with our case. It's a Lambda. There's a Lambda here that can post new items to the table, and it can delete items to the from the table. They're essentially our administrator, actually, isn't it? Yeah. Now, uh, whenever there is a state change in your DynamoDB table, you can actually have a Lambda triggered as a result of those state changes. So we've got a Lambda down here, and this Lambda is triggered when there are state changes in the database. Typically, what the Lambda might do is send out some sort of notification. So that could be, send an email to somebody or post a message on a Slack channel or something of that nature. Now, I didn't want to get into that because that would be too involved, really. But what I want is I want this Lambda down here to also just do a console log to its log stream, and it just console logs the fact that a record has been deleted from this table or a new record has been added to the table. And so what you need to find out is, okay, the Lambda itself is pretty straightforward, but how do we connect this Lambda to the database in terms of the triggering? You need to do a little bit of exploration on that. You may or may not remember, like how it actually works is whenever there is a state change in the database, DynamoDB keeps a record of each change, as well as changing the actual table itself. It also keeps a record, which we refer to as a stream of records of the changes that are happening in the table. And that set of changes is referred to as a stream. And we want to kind of feed that stream to this Lambda. And how it actually works is that the Lambda service periodically polls the DynamoDB service, asking it for the most, the set of entries in that stream, the new set of entries in that stream since I last polled you. So there's this periodic polling going on between the Lambda service and the DynamoDB service. And when the DynamoDB service returns with the new entries in the stream, then those entries are passed into your Lambda function and it can process them. But you need to find out essentially how do I make this connection here. Yeah. Back to the spec. I don't know where I need to actually reload this thing because sorry, now just give me 1 second because Zoom is putting stuff in my way. So that Lambda that's being triggered, it just needs to console log this kind of stuff. Delete, and then just the actual details of the table item that was deleted, or post and the details of the new item that was added to the table. And it'll get the kind of details of the item itself. They will be included in the stream that's kind of made available to that Lambda. Don't know if all of that is anyway clear to you or not, but I go back again, sorry now, to this guy. This Lambda, like any other Lambda, it receives, the first parameter is an event object. It'll receive an event for every state change. And that event object will indicate, was it a new item added to the table or was it an item deleted? And it will have the details of the item added or deleted. So you'll get all of the information about the particular item itself in the event object, and as well you will get it. You will kind of find out whether it was a delete or a post or an update. Update doesn't apply in our case, but so all of that information is in the event object that's available, that's kind of provided to the Lambda. And it just needs to console log it. It's going to have its own log stream, obviously, its own log group. So in terms of checking that it's working properly, you just have to look at the log stream to see is it console logging the right stuff. There can be other console logs, like up to now we have used console log in our lambdas mainly as a kind of a debugging aid, and that's fine. You can still do that. It's just that in the Salmon specification, I am itemizing particular console logs that I want some of your lambdas to generate, as well as the ones that you might have for debugging purposes. Back to the spec. The last thing then is the grading spectrum. I think the grading spectrum is hopefully uh, self-evident. I don't have to talk my way through it, except for maybe if you're aiming for this kind of grade band here, um, 85 plus, then you would need to look up this notion of lambda layers. There's two options I'm giving you. You can either try and include lambda layers in your solution or multi-stack app in your solution. Just to briefly explain and you pick one or the other. What do I mean by lambda layers? So you've got an application that has a number of lambdas in it, and those lambdas are importing modules from the node modules folder. So the way it actually works when you do a CDK deploy, each lambda, if I just go back to VS Code, each lambda will essentially have its own copy of the contents of the node modules folder. Yeah. But the contents of the node modules folder is the same for every lambda. So packaging it in each lambda is probably overkill, but that's what's happening at the moment. And by the way, that code is actually being stored in an S3 bucket. So if we really poked around the S3 service, we'd find a bucket or buckets in there that contain that's actually holding the contents of the lambdas themselves. But back to lambda layers. So each lambda essentially has its own copy of the node modules, and that's being uploaded when you do a CDK deploy. But is there any way we can sort of share the same node modules? And it doesn't have to be node modules. There could be other parts of your code as well that's being shared across multiple lambdas. Is there a way of kind of uploading it once, but then kind of linking it back to each individual lambda? And the answer is yes, and the answer is by using this idea of lambda layers. And again, this is something that you would encode or describe in the CDK stack. You don't really change your lambda functions at all. But if we go to the lambda service, and just take any lambda at all. You see here where we have layers, and this lambda doesn't have any layers because we haven't described that in our CDK. But if there was a layer, then we would see it being mentioned here. Essentially, kind of the lambda code, your lambda code is kind of sitting on top of a particular layer or layers of third party or whatever. It doesn't have to be third party. It could be that a layer could contain code that you have written, but that code is actually being used by multiple lambdas. So that's this idea of lambda layers anyway. So you might want to pursue that, or you might want to pursue this idea of multi-stack app. At the moment, every application that we have written just contains one stack file. But for very, very, very large applications, you might want to break that up into multiple stacks. Stacks now are different from constructs. Okay. But you might want to break a large application up into multiple stacks. And remember, a stack is the unit of deployment. When we do a CDK deploy, because our applications to date, and indeed for the rest of this module, will ever only consist of one stack, we just do CDK space deploy and hit return. But if you had a multi-stack app, you would go CDK space deploy, and then you'd specify which stack do you want to deploy. Or you could go minus minus all, and it will deploy all of them. So the stack is the unit of deployment. And if you do have a multi-stack app and you've made some changes, but it's to one particular part of the application, i.e. to one stack, then you only need to redeploy that stack. Whereas if you've got the entire application in one stack, then you're CDK deploying the entire application. And clearly that takes longer. The actual deploy process itself is slower in that case. So that's kind of the advantage of breaking in an application up into multiple stacks. Now, the how you would break it up, it would have to be some sort of logical division. You wouldn't just randomly just chop out parts of the larger stack and just put it into a separate stack of its own. I guess it should be along some sort of logical grounds. So you may want to have a Google about multi-stack apps with CDK and find out what's the mechanics of it, and pursue that. So so there are a number of parts to this specification which do require you to do some research on your own. There is API keys. There is the data streams, the DynamoDB streams. That's kind of, I didn't mention that term in here, but that's what it comes under. And DynamoDB streams and triggering a Lambda to consume a DynamoDB stream. You'd have to read up on that, do some research on that. And if you're going for that 85 plus, you'd have to do some research on Lambda layers, all in the context of the CDK, or multi-stack in the context of CDK. Because multi-stack really is a CloudFormation thing. CDK is just availing of it. Right, I've done enough talking really, I think. I'm going to open the floor to ye if ye have any questions for me at this stage. No? Okay. I will accept questions over Slack. I guess, as with anything, it's not until you get stuck into this that questions come to you. So I'll accept questions over Slack as well. I'm trying to think, is there anything else I wanted to? There was one final thing that I want to go back on really from earlier. This lab here had an exercise in it. Where was the exercise? Yeah, this exercise here. And so we had an endpoint which was get/movies/movie ID. And the exercise then said, well, if let's supposing there's a query string option available, and the query string, the ID of the query string is, whereas get movie/movie ID will just return the movie uh, item from the table. If this query string option is included, then we want the response to also include the cast members for that movie. Yeah. So that would mean that the Lambda would need to not only read from the movies table, but it would also need read from the movies cast table. That's when we had our data stored across multiple tables. Okay, which doesn't apply um, in the case of the spec, but the general idea is that the general point that I want to try and get to is that the contents of the response can kind of vary depending on, in this case, the query string being included or not. Yeah. And the solution, do I have it here? So it's the get movie by ID. That's the Lambda function that's being triggered in this case. And so what I did was I first of all defined the structure of the body of the response as a type. And we can see that in all cases, okay, it's the data property first of all. The data property is the main property in the response. That's kind of dictated by the Lambda kind of service itself, let's say. The Lambda service for a HTTP endpoint Lambda. And the structure of the data property, then we have control over that, because that's obviously going to vary from application to application. But for this particular Lambda, I'm saying that there are two parts to it. There's the movie part, which will contain a movie, obviously, and then there's a cast part, which is optional, and it will contain an array of cast items, and I've got these two types are defined elsewhere, yeah. And then in the body of the Lambda, at the beginning, what it does is it's getting the movie, checking that the movie ID is valid and all that kind of stuff. Then it sends a read request to the movies table. And oh yeah, and it's uh, let's see, what is it doing? Am I looking at the right one? Oh yeah, here we go, where we're just setting the movie part of our response. And then in the rest, the code down here, this is where I'm checking to see, well, was there a query string in the request as well? And if there was, get the necessary data and then add that onto your response body. And then eventually return the entire response body. But it's a bit like the the exercise that was in the other lab, this idea that you have to declare the structure, the overall structure of the response up front. Now, in this case, I'm doing it here, right? I think when I was talking about a similar exercise in another lab last week, I put this kind of code buried inside the Lambda. Clearly, this is slightly better, but either way, the general point is that you have to declare the overall structure of the response, even the optional parts. And again, this kind of goes back to the constraint that TypeScript puts on you, which is that uh, you can't dynamically just start adding properties to an object. Just doesn't allow that. Right. that's it. I have nothing else to talk to you about. So I'll leave it at that for today. And again, contact me on Slack in relation to the assignment when you start working on it. Okay. Enjoy the midterm, if enjoy is the word, but I'll talk to you later when we come back. Bye-bye.